All right, so question number 5 on this problem set is what cofactors might be involved in the following reactions? All right, so you guys have not seen any of these chemical reactions before. You'll likely at least see this one in the class. We may or may not get to this one. But these are two actual enzymes found in nature. All right, well, at this point, what I'm hoping you guys will start to realize is start to recognize some of the chemical pattern or chemical reaction patterns that occur in nature. And one of these is the common types of reactions that different coenzymes carry out. All right, so in this first reaction, the reaction carried out by thymidylate synthase, all right, if you look closely at the reaction, the only difference occurs right here with the addition of this methyl group. All right, well, there are two different possibilities from your table 13.1 in your textbook that for coenzymes that could be involved in this process. All right, and I will accept both of them. All right, the first one is vitamin B12. All right, B12 is involved in alkylation reactions. All right, you don't know enough about how it works yet to be able to say one way or the other whether it'll work in this case, but B12 can carry out alkylations, and that's exactly the type of chemistry that's happening here. All right, the other possibility is tetrahydrofolate. All right, tetrahydrofolate, according to your textbook, is involved in 1-carbon group transfers. Well, we just transferred a 1-carbon group over here to make thymine. All right, it turns out the actual answer for this enzyme is that it is tetrahydrofolate, but as I said, I will accept vitamin B12 as well. All right, now looking down at this reaction here. All right, this one's definitely a little odd when you first start looking at it. All right, the first thing you want to be doing anytime you start out here and trying to figure out what coenzymes are involved is to figure out what is actually happening with the molecule. Well, in this case, they help us out quite a bit by labeling the CO2 in red, so we can track where that portion of the molecule is going anyway. All right, hopefully you can envision, the phosphate here is coming from the GTP. We end up making GDP and phosphate. All right, so really all that's happening is this carboxyl group is leaving as CO2. Well, looking at the table, I don't see anything on this table that's labeled as a decarboxylase or decarboxylation reaction. I do, however, see a coenzyme for a carboxylation reaction. Well, some enzymes, it turns out, are actually named for the reverse process, the reverse reaction. That's because the reverse reaction in a lot of these cases does occur actually, but usually when we're learning metabolism, we think about them occurring in one direction or the other. And so in this case, this is an example of a carboxylation reaction, which means that the coenzyme biotin is going to be the coenzyme you're looking for.